The objective of this lesson is to subtract fractions with unlike denominators by creating equivalent fractions. In previous lessons, students learned how to subtract fractions with related denominators. They have also learned how to create equivalent fractions using the common denominator strategy. Today, students will extend their knowledge to subtracting fractions where both addends will need to have equivalent fractions generated to have a common denominator. A common mistake here is that when multiplying the denominators to generate equivalent fractions, only the denominators are multiplied. This is incorrect, and it is important to remember to multiply both the denominator and the numerator by the same number. Let's begin with our first problem. Kyson made a pizza and cut it into fourths. He invited a friend over to help him eat it. When they had finished eating, there was 1/3 of the pizza left. Describe the size of the remaining pieces. The original pizza is represented with a fraction circle that is portioned into fourths. The whole is the one pizza, or one fraction circle. The leftover pizza was 1/3 of the whole pizza. This will be represented by 1/3 piece. The equation to represent this problem would be the one whole, or 4/4, minus the amount eaten, S, equals 1/3 left, or it could also be thought of as 4/4 minus the 1/3 left equals the amount eaten, S. In order to subtract, the fractions must be equal-sized pieces, which means they must have common denominators. This can be found by multiplying the denominators together. 4/4 will be multiplied by 3, and 1/3 will be multiplied by 4, for a common denominator of 12. 12 is the common denominator because 3 and 4 are both factors of 12. 4/4 is equivalent to 12/12, and 1/3 is equivalent to 4/12. The new equivalent equation would be 12/12 minus 4/12 equals S. Using fraction circles, turn each of the pieces into twelfths. The 4/4 changes to 12/12, and the 1/3 changes to 4/12. Now we can subtract the 4/12 from the one whole pizza, or the 12/12, for a difference of 8/12. They ate 8/12 of the pizza. The remaining pieces are in twelfths, or the 1/3 left over is equivalent to 4/12. Let's try another problem using a number line to model. Hugo bought an avocado plant that was 1/3 of a foot tall. After 3 weeks, it grew to be 1/2 of a foot tall. How much did the avocado plant grow in 3 weeks? The whole for this situation is 1 foot. This will be represented on the number line at the number 1. There are a few equations to represent this problem situation. One equation would be the 1/3 foot plus g, amount of growth, equals 1/2 foot. Another way to solve this problem would be the 1/2 foot total height minus g, amount of growth, equals the 1/3 initial height. And one more way to solve the problem would be the 1/2 total height minus the 1/3 initial height equals g, the amount of growth. Let's use the last equation to solve for the growth. On the number line, draw up to the 1/2 mark. This represents the total height of the plant. The problem states to subtract 1/3. The 1/2 and 1/3 do not have common denominators. Let's multiply the denominators together to get a common denominator. 2 times 3 equals 6. The common denominator will be 6. Multiply the 1/2 by 3 and the 1/3 by 2. The new equivalent equation is 3/6 minus 2/6 equals g. On the number line, this will be modeled by partitioning the whole into 6. The total height of the 1/2 is now 3/6. The equation states to subtract or move down 2 6 spots. Jump back 2 6 spots to land on 1/6. The plant grew 1/6 of a foot in 3 weeks, or g equals 1/6 foot. The objective for this lesson was to subtract fractions with unlike denominators by creating equivalent fractions. We met this objective by generating equivalent fractions in order to solve real-world fraction problems using the common denominator strategy. We also used number lines and fraction circles to model the subtraction.